Let us discuss about the Doppler's effect. The Doppler's effect is a beautiful phenomenon. In case of sound, Doppler's effect is the change in the apparent frequency of the sound heard by the listener when there is relative motion between the source of the sound and the listener. For example, when a train approaches a man standing on the platform, the apparent frequency of the sound seems to increase, or when the train is moving away from a man at the platform, the apparent frequency of the sound seems to decrease. That means the apparent frequency is different from the frequency of the sound emitted by the source. So when there is relative motion between the source and the listener, relative motion is if source is moving away or source is moving into the listener, listener is moving into the source of sound, or listener is moving out from the source of sound, or the listener and the source of sound are moving away from each other, or the listener or the source of sound are moving towards each other. All this is connected in the relative motion. So there is apparent change in the frequency of the sound emitted. Now, the Doppler's effect is a typical wave phenomenon. That means the Doppler's effect is applicable to all types of waves. May these be sound waves, may these be electromagnetic waves, may these be transverse or longitudinal. If it is a wave, it obeys the Doppler's effect. And what is Doppler's effect? Again, Doppler's effect is the apparent change in the frequency of the wave when there is relative motion between the body emitting those waves and the body receiving those waves, whether it may be sound or light. Discussing about the Doppler's effect in detail, let the frequency of the sound produced by the source be equal to nu, and the velocity of the sound in a medium will be equal to v. So the lambda, the wavelength, is equal to velocity divided by frequency. So lambda divided by nu. Let us take the case in which the source is moving in the positive x direction with velocity vs. The medium is moving with the velocity vm in the same direction, and the listener is moving in the same direction with velocity vl. Now, if the sound produced by the source has got a velocity v and the medium has got velocity of vm, so the velocity of the sound with which it travels is equal to v plus vm. Now, as the source is also moving, that means relative velocity of sound with respect to source will be equal to v plus Vm minus Vs, as these are moving in the same direction. If the frequency of the sound produced is equal to nu, then the apparent wavelength of the sound lambda dash will be equal to V plus Vm minus Vs divided by nu. It is the apparent wavelength of the sound. Now, as VL, or the listener, is moving in the same direction with velocity VL, what is the relative velocity of the sound with respect to the listener? That is V plus Vm minus VL. As lambda, or the apparent wavelength, is equal to V plus Vm minus Vs divided by nu, that means the frequency heard by the listener, that is equal to nu dash, is equal to V plus Vm minus VL divided by lambda dash. That means apparent frequency is equal to the relative velocity of sound and the listener divided by the apparent wavelength lambda. To know the apparent frequency, we will substitute the value of lambda dash here in this equation. That means nu dash is equal to V plus Vm minus VL divided by V plus Vm minus Vs divided by nu, that nu comes here. So this is the equation for the apparent frequency of the sound heard by the listener. This is the frequency of the sound that is produced by the source. If we take another general scenario, in that the medium is moving in this way, opposite, in that case the sign of Vm is reversed from plus to minus. In that case, apparent frequency is equal to V minus Vm minus Vl divided by V minus Vm minus Vs into nu. That means the apparent frequency is different from the actual frequency of the sound that is produced by the source. In another general case, if we take the velocity of medium be equal to 0, in that case the apparent frequency nu dash is equal to V minus Vl divided by V minus Vs into nu. Why? Because here Vm is equal to 0 as the medium is at rest. Putting the Vm is equal to 0 in this equation, we have got nu dash is equal to V minus Vl divided by V minus Vs into nu. This is the general form of the Doppler's effect. In next lecture, we will discuss about the different scenarios. Thank you.